Hello everyone, this is my bot Pac-Attac, Pac-Attac I, Pac-Attac II, and Pac-Attac III as it's improved over the competitions. I just want to do a quick video here about some of the engineering, design, and justifications that went into each of these as they improved. We went from Pac-Attac, gained 1 win and 2 losses, to Pac-Attac II, gain a 3rd place, all the way to Pac-Attac III, gain 1st place in the Plastic Antweight division recently at the Utah Bot Brawl. Gained 5 wins and 1 loss. So first of all, Pac-Attac is a Meltybrain. Meltybrain essentially works by spinning. The whole bot spins. There's no separate moving parts, just the wheels right here. And how it's able to be driven basically is the whole thing spinning, and this LED strip right here will light up whenever the robot thinks it's at 0 degrees, which is how I have it programmed. And so that way, me as the driver, I know what direction the robot thinks is forward, and if I push up on my controller, it will move in that direction while it's spinning. So essentially it's just constantly spinning, about 1500 to 2000 RPM, but by turning these motors on and off at the right times, it's able to make progress in a direction while still spinning. And that allows the entire bot's weight to be put towards this tooth, since there's no stationary part really. So of course you can work with the physics and make the outside heavier and the inside lighter to store more energy essentially. I wanted to start off with Pac-Attac I here. So this one was entirely 3D printed. You can see here Pac-Attac, and this lid comes off. Inside you can see this one, I started with brushed motors. So you can see the brushed motors right there. Got an Arduino, and it had the battery in the back here, a 2S 450 milliamp hour LiPo battery. And this one just looks kind of ancient in comparison to what's in the newer ones, but yeah, we have motor driver chips here. We got LED driver chip. This little vibrator motor, I ended up not really needing it, but it was intended to be if Pac-Attac got stuck flat on a wall or stuck high-centered or something, I could run that vibrator motor so that it could get off. Has a optical encoder here, which ended up not being needed in the later ones. I just relied on the accelerometer. You can see there's an accelerometer right here in the center. And yeah, this one I really learned how weak 3D printed parts can be. This entire weapon ring is about 1/4 pound, and it broke apart after a few hits. And so you can see where I tried to tape it back together because I ran out of spares. So yeah, this one is the one that got it all started. If I hadn't got this one working well, I don't know if I would have gone on to make the other two. So despite it not working that great, it is a pioneer. Oh, by the way, there's a little LED on the bottom so you can see where you're going if you're upside down. Anyway, let's move on to Pac-Attac II, where you can see some improvements that have been made there. So here's Pac-Attac II. Keep in mind, these are all broken bots from battle. Most notable improvement here, well, there's several parts missing, but see, it has a brushless motor. Brushless motors heavily improved the performance over Pac-Attac I. Here, these are 1806 motors, so kind of small, but they're still able to respond much faster to changes compared to Pac-Attac I's brushed motors. And for a Meltybrain, that's really important, for it to respond to changes quickly. These motors are able to almost stop entirely when told to, even while the bot is spinning under full speed. And that allows it to translate faster in a direction while it's spinning. Here we still have same Arduino. You have some transistors for driving LEDs. This one, instead of having that row of little LEDs. It has a LED strip right here and a couple RGB LEDs. This LED strip heavily improved the visibility over Pac-Attac I. The problem with Pac-Attac I here is that these LEDs, they weren't super bright, but also from an angle, you couldn't see it easily because they pointed straight up. And so in the sun, it made it very difficult to drive for an outdoor competition. Okay, you couldn't see where you're going. This one, this LED strip, it is very bright from a much wider viewing angle, and it's white. It's a cob LED because it's made up of a whole bunch of little LEDs there. And this made driving so much easier in a light environment. So yeah, we removed the vibrator motor, went to brushless motors. The fundamental design of the frame didn't really change. Still has the battery in the back, circuit front, just adjusted for brushless motors. And what this shows is how weak that frame is. Pac-Attac I doesn't look that bad because it was eliminated before it got any super big hits. But Pac-Attac II was able to stay in long enough that now the frame started getting torn apart. You can see here where the LEDs are now part of the top plate, necessitated by this cob LED being a flat plane. You can't easily just stick that underneath. You can see here I went with CNC machined weapon, and my intention was that I had 2 of these weapon plates. This is what a full one looks like. So I had 2 of these weapon plates with a 3D printed ring sandwiched in the middle. And that was intended to be for balancing. You have these little holes here. I could put little washers and nuts in to make sure the whole bot is balanced. And that's super important when the bot is spinning at high speed. Otherwise you'll get a heavy wobble and it won't spin well. These were made with send cut send, and they're pretty thin. And here's our balancer ring. But you can see here, there's no teeth. They got broken off. And that was the problem with this weapon ring design, is all of my spares, they all broke like this. You can see where that was the tooth, broke apart, and that showed there was something wrong with this design. It was obviously quite weak right there. And the other thing wrong with this design, that was the same thing wrong with Pac-Attac I, it just didn't get heavy enough hits to show it, is that the screws all pulled through. You can see right here, that pulled right through. This one broke off. Yeah, a couple others pulled through. So this is showing several flaws that all need to be fixed for the next version, but also several improvements. Most notably the brushless motors, and starting to have non-3D printed parts, which for this plastic antweight competition, CNC machined ABS was allowed. So let's now talk about Pac-Attac III over here. Pac-Attac III, assembled, you could see a few things. One, there's some cracks in the frame from the most recent competition it had. We'll talk about that in a little bit here. Most notable first, from the bottom, you can see it's got more screws. Still 2 on the back, but they have washers in them to help prevent the screw from being pulled through. It's got 6 screws on the front, 2 right here that screw directly into the weapon, and 4 that go all the way through to nuts on the top. From here we've got our same bright cob LED. Here I've also got some RGB LEDs in the back that I want to use in the future for displaying text or like an emoji or something on top. We've got bigger brushless motors, but still the same design is pretty much there, same shape, size of the bot, same size tooth essentially, but a lot of internal improvements that I learned from Pac-Attac I and II. So let's go ahead and well, I'll show you one quick trick it does before we take it apart. Oh yeah, it plays a little Pac-Man intro tune right there on the motors. So let's go ahead and take this one apart. So inside here, let's talk about a bunch of improvements that have been made. So you still have the same battery, same general layout. You have the accelerometer in the middle, and you have the two brushless motors. The motors have been upgraded. They're now 2207 size, which is basically the largest diameter can I can put in here before it gets too large for this frame. You can see here the cutouts on the top. The motors essentially were even with the top. Kind of see it here, how they're even with the bottom as well. So in here we've got the larger brushless motors, which improved greatly on the already great performance of Pac-Attac II's brushless motors. You have the same ESCs. You've got one there, one there. Just these little ones I got off Amazon, Hack RC. They're 35 amp, 2 to 5S D shot. You can see a much larger amount of plastic compared to the previous weapon ring. If I overlay that, you can see all that extra plastic there. And that's where these old ones kept breaking. So by adding more plastic there, that meant it did not come apart. In fact, it never cracked there in any of my battles. You just got a blunted tip mainly, but none of them ever actually cracked. And that is mainly down to it having a lot more plastic here, plus it's much thicker. So we're going to compare the thickness right here. See, it's over double the thickness. And this is still ABS. I actually machined this on my own CNC machine. I didn't have that last time. But yeah, this is all ABS, one solid piece. See the circuit board in there. This is a custom circuit board that I designed myself. It's based around the ESP8266 microcontroller, which here's a partially populated one. There's a Wi-Fi antenna on there. It's got 5 volt and 3.3 volt regulators. Let's see, a little bit on the bottom. This right here is a fully populated one. It's covered in hot glue for vibration resistance. It's got the little accelerometer board here. It's the MPU 6050, the same accelerometer that's been on all of them. It's kind of the limiting factor now. It'll be changed out later, most likely, because this only gets up to 16G. And so you can see its position in the center. It's slightly offset from the center, and so I can't get much faster than 2000 RPM without that maxing out. So the motors are able to go much faster. On here you've got the little programming header and a place for the RC receiver to plug in, which right now I've been using the FlySky. One nice thing about having Wi-Fi on here is I can program it once with this little programmer board here, and after I've done that, I actually have a piece of code in there that allows it to accept code over Wi-Fi. So it'll connect to my home Wi-Fi. It's got a lot of special stuff around the Wi-Fi code, so it doesn't mess with its driving when it's in a competition. But if it's at home, it'll connect to Wi-Fi and allow me to upload directly to it without having to take the whole bot apart. So that way I can make little calibration type changes in here and then just keep driving without having to constantly take the whole top off, for example. So something that's been an ongoing challenge with all of the Pac-Attacs is the outward G-force that wants to pull the wheels off. Pac-Attac I had this issue, and here I kind of solved it by have a 3D printed hub, and that is actually super glued with a little C-clip in the middle to the motor shaft so that it can't come off. Pac-Attac II, we had a screwed on clip that then has a little paper clip running through it, and that prevents that screw clip from unscrewing, because it wanted to do that constantly, because these wheels are spinning one direction mainly, but when you're driving thanks to how a Meltybrain works, they're getting pushed the opposite direction quite often. So that screw, even if it's constantly being tightened by your normal spinning, will come off quite fast when you start to try to drive straight. Pac-Attac III, I actually didn't have any issue really with the nylock nuts. I did have a couple issues of the motor shell actually coming off, which you can see on the back here what was happening. That little C-clip that was on the back preventing the shell from coming off like this, that was popping off because it was the weakest point. And so I actually soldered a ring around the C-clip so that the C-clip was basically stuck on, it couldn't expand, and that solved that problem. Yeah, you can see here, got the wheels. These wheels went through all the battles, no replacement needed. Got the RC receiver right here. Oh, you're probably wondering what this little wire is right here. This is not an antenna. That is actually meant to be an anti-static grounding wire. The Arduinos, they are pretty hardy against static electricity, and I never had any issues with random resets or anything. But this ESP chip, it actually started to have issues where it would intermittently get into an error state or a bad state where it would partially run some of the code but then just freeze, and it ended up being caused by static electricity. So you've got a bot spinning with foam wheels, ABS plastic on a wooden surface. It would build up static, and it would occasionally discharge through the LED actually. But by adding this grounding wire that goes, when it's put together properly, this is touching the metal screws, and then you've got this one touching the metal motor. It just helps discharge before it builds up and zaps through the LED into this. And that solved my intermittent rebooting problems. So yeah, that's just a quick little overview of Pac-Attac I to Pac-Attac III and some of the design differences between them, mainly better motors, better processor, and most importantly, a better weapon ring. But essentially still the same concept on all of them. Oh, I said I was going to talk about this crack here. This crack shows that the bot was actually still fully driving even with this crack here. And what that shows is basically a big shift. It may not look like it, but it's a shift between the bot frame having the weapon mounted onto it and the weapon having the frame mounted onto it. So in Pac-Attac I and II, the rest of the bot was heavy enough that the frame mounted onto the bot, and then it kind of provides support for the large hits, if that makes sense. That's why we had the screw pull through. That's why we had the whole top essentially get cracked and come apart, and this whole top came off. Here I was able to especially this circuit board is half the weight of the one in Pac-Attac II, for example, just by making a lot of surface mount parts and whatnot. So that's one change. Also, some of the plastics all been changed. So the weapon here is a heavier weapon ring than the previous two bots, and that means that it is the main support structure. So everything's bolted onto the weapon. So even despite that crack, because it's bolted on back here, bolted on here, it still fully drives. And you can see in, we've got one over here, another frame. This one is an old Pac-Attac III frame I switched out after a couple battles. You can see it's got a crack in there as well, and it still kept driving. Pac-Attac III, the only loss it had was because it fell in the pit. Because it went upside down and I couldn't see where I was going. That is my mistake by picking too weak of an LED. This bottom LED is not bright enough to see in a bright outside environment. So, and it got flipped upside down, couldn't see where I was going, and drove into a pit. That is the basic design decisions between Pac-Attac III, II, and I. Essentially, Pac-Attac I walked so that Pac-Attac III could run, because Pac-Attac III did very well. Don't know how I'd do at like Norwalk or somewhere with a lot more variety of competitors, but we had a good variety of spinners and flippers and other bots. Horizontal spinner was the hardest one that provided the most cracks in my frame. Couple things, I guess, that I miss about Pac-Attac I. This is probably the only thing I really miss about Pac-Attac I is the top plate has no electronics in it. So you can just take the whole thing off and put another one on without having to unplug anything. It's something that's kind of difficult to do when you have a whole bunch of LEDs that need to be aligned in the right spots. Overall, this one works. I never actually replaced the top frame the whole time. What's coming in Pac-Attac IV? Well, we have we're going to get a brighter LED for the bottom. So I can drive upside down in broad daylight. There might be larger motors, but these honestly were getting to the point where I don't know if I'd see that much improvement by getting longer motors, like 2212s, for example. Want to get a better accelerometer that can handle a higher G-force, so I can get hopefully over 2,000 RPM. Probably going to keep a similar weapon design, but who knows? I'll play with it. Probably similar shape, and some fancy stuff might be coming. Like, I've been wanting to try out, even if I don't use it at a competition, just experiment with an auto finding mechanism. Basically, it would consist of some optical emitters and detectors, so it can detect if something is not necessarily the distance, but detect if something is in front of it in that little area, like little proximity sensors. Those would be fast enough that there is a possibility while it's spinning I could map there is something regularly right here, or there is something over here, and have it auto aim the 0 degrees direction in that towards that object. So then I just have to push the control forward and it would try to attack that object. Of course, wouldn't be able to easily tell what is a wall versus what is an opponent, and it might not even be allowed to do some of that auto stuff depending on what competition I go to, but it would be fun to experiment with, because this ESP8266 chip, this is much more powerful compared to the Arduino Nano I was using. This has I think an 80 megahertz processor clock speed, got a lot more storage, more RAM, whatnot, just all around faster, better chip, except for the amount of I/O it has. Doesn't have very much I/O because I use a lot of it for the SPI for these RGB LEDs, which I don't even do much with right now, but it will eventually have something cool. Let me know if you have any specific questions about Pac-Attac III, Pac-Attac I, and Pac-Attac II. Well, there's just its top. I've got a write-up on my website about Pac-Attac I. I have not yet really written much about Pac-Attac III. I might actually hold off on putting some of the code out for now, just because it is extremely messy and I don't know how helpful it would be. But there we go.